I've been thinking a lot recently about querying streams. You get streaming data, and how do you want to ask it questions? Do you just want to do key lookups? Do you want to do analytics? There's all these different ways to do it. And I thought we'd just spend some time, just me in the studio, kind of riffing on that topic. Let's listen into me thinking about querying streams. Hello and welcome to another episode of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I'm here in the studio by myself today. I kind of had some thoughts about querying streams that I wanted to work through. So let's just dive into that topic. Now, this started like last June or July, and as I record this, it's like the beginning of May 2023. So almost a year ago, my friend Robert Zick tweeted something about querying streams, and we'll have a link to the original tweet that kicked this all off in the show notes. And Gunnar Morling jumped in, and I was there, and it was just kind of this interesting conversation about how do you query a stream, and I want to talk through that. There's a lot to it. There is no single answer. It very much relates to real-time analytics. I think it's a very pertinent question. So let me just kind of tell you what I mean. So if you just back up and think about a stream, and it's fine if you just make this a Kafka topic, right? It could be Kinesis, it could be Pulsar, it could be anything, whatever you want to think of it as. You could make it some abstract stream, but there's a Kafka topic and there's messages arriving in that topic. Now, the most obvious thing to do with these events in a stream or messages in a topic or whatever they are is simply to consume them, right? Like if a message, if you've got this perfect world lined up where a message is a self-contained unit of work and it's got all of the data you need and you've got some computational task, consume the message, do your computation, produce your output, maybe it's, to another topic or to wherever, that kind of block diagram of stream processor, however that stream processor is implemented, is cool. Now, we don't need to know inside that box if it's stateful or stateless or what. But this kind of get the message, do the thing, produce the output, that is how event-driven services live their lives, right? So if you're doing reactive microservices, that's kind of what you do. You get a message and you do a thing and you put the results somewhere. And that's good. And that's kind of should be how a lot of event processing works in an event-driven system. But the question from this epic Twitter thread from a year ago is, what if there's stuff you want to ask questions about? And the original thread, I don't think I said this before, was about a part of the Kafka Streams API called interactive queries. It's about some new stuff in the IQ API. We'll get back to what interactive queries is in a minute. But what if there's something in that stream that you want to ask about? The consume and do your compute and put your results, that's not a query. That's not asking a question. And a stream fundamentally, or if you think of it as a log, fundamentally, you don't query a log, you scan a log. But then queries are sometimes necessary. So I've kind of thought about this a little bit, and we talked about it and batted it around. And there's a couple of taxonomies I want to give. I just want to get these ideas out on the table, propose some answers, and to some degree in this episode, you're hearing me think through this too. So, let's think through this together. I've got a stream and I want to ask it questions. I think broadly there are two kinds of questions, and these terms should sound very familiar, but we might have sort of transactional kinds of questions and analytical kinds of questions. Of course, those are broadly speaking the categories of databases there are. But what I mean by that is, I'm querying a stream and I might want to do what is essentially a point lookup. I might have a key and I might want to get one thing out of that stream. What is the current state of that thing? And so if you've got a stream that is like a change log, it's a series of updates of some entity whose state is evolving over time. And every time the state of that entity changes, you serialize that state and you produce that new message to the stream. Well, that's a change log, and that could be the output of a change data capture process. We've recently spoken to Gunnar Morling on the podcast about Debezium and CDC and stream processing and that whole thing. We'll put a link to that episode in the show notes. That topic could be the output of CDC or some other thing where it's just the unfolding, evolving state of some entity in the world. In that case, in that kind of transactional query of a topic, I really just want to take that stream and turn it into a table. You can just imagine a hash table, right? I've got a key by which I want to look up these entities, and I just want to know the most recent value of that entity. That's the simplest form of that transactional query question. That's one thing I might do. Now, I just reduced that to a key value lookup. That's an assumption. Maybe I might need to do more than one kind of lookup. Maybe it's a topic of change data capture of users, and I need to look up by username or look up by email or look up, I don't know, some other thing. So maybe I need more than one index, but in general, that kind of point lookup, that's the transactional lookup kind of case. Or I might want to ask what we might call analytical questions, which is not what's the current state of these things, but fundamentally the question is, what has happened with these things? So in an analytical query, whether it's a stream or a table or bulk data or batch or whatever, in a fairly fundamental sense, I'm scanning over many things. I've got some big collection of things I've probably filtered on some dimensions, and I'm scanning the remaining set, looking at some field in there, we usually call it a measurement, and running some kind of reducing function over the values in that measurement, right? What's the average temperature of all the smart thermostats in 80002, the zip code in North Metro Denver, right? That's an analytical query. So look at all the things, get some subset of them, pull some measurement out, run a reducing function over the measurement. There you go. So I could have transactional queries. I could have analytical queries. Broadly speaking, those are the two kinds of questions I might be wanting to ask. And then when you dig into how do I do that with a stream, I can think of 4 ways. And I'd really be interested to hear if you can think of more, or if you think I've got the taxonomy a little bit wrong. I do not propose this as a final thing, but really as a starting point for discussion. And I think it's an important discussion to have because I feel like this is a little bit incompletely formed in sort of the collective software architectural consciousness that's a weird way to put it, but you know what I mean, the current thinking about stream processing. So anyway, these 4 ways. I'll say what they are first, and then I'll expound on them a little bit, and we'll see where we get. All right, I've got a stream, got a Kafka topic, things are happening. I could dump that into a data lake. It's not much, but it's honest work. Right? So just take that topic and write the things into a data lake and have some way of getting at them later. The implication being, if it's in a data lake, I've probably got some kind of SQL layer on top of that. There's some sort of structure to the data, and I can access it later on, and do my filtering and my scanning and my reducing and produce that to a dashboard or to whatever it is I'm going to do. So put it in a data lake. I could dump it into a relational database. I could use a stream processor, or I could use a real-time analytics database. Let me say those again. I kind of went into data lake a little bit, and I said I just wanted to say them. So dump it to a data lake, dump it into a relational database, use a stream processor, or use a real-time analytics database. Now, I put real-time analytics database last, and it kind of seems like maybe I'm trying to privilege that one, or let's dismiss these first 3 silly approaches, and then we'll get to the real one, which is Apache Pinot. I don't mean that. Obviously, I look at things through that lens, but I think these are all proper first-class options. Now, let's go back to data lake. Talk about that. That happens a lot, and I don't want to present it as somehow wrong. When you've got the kind of the warning thing here, I think, or the thing that is a concern about this approach is when you've got streaming data, you've got this system that the data infrastructure is optimized for real-time processing, event at a time processing, low latency computation done on events that are unfolding in the world. I put it into a data lake. That's the opposite of that, right? That's, let me store this data as this sort of unstructured morass of stuff that I'll run batch jobs on later. So that's appropriate for certain kinds of offline analysis. That might be good for, say, a business analytics team who, although no one wants more latency, they are not really the people who need real-time things, right? They just need to know what's happened fairly recently, and maybe last quarter is interesting to them, right? They don't need to know what happened a second ago. So you are sacrificing any kind of real-time-ness by doing that, but it might be very appropriate to dump your stream into a data lake from which you can query it using all of the usual suspects in that part of the data ecosystem. So data lake. Somewhat more interactive things. Next in the list, I had just dump it into a relational database. So if this is a Kafka topic, I can have Kafka Connect and have a sync connector that just goes into the database of my choosing. Suppose I'm a Postgres shop. I can take this topic again. Imagine it's a topic of entities. Kind of changes on entities. I can put that into a table and query the table. And what's nice about that is, boy, that just works, right? There's very little confusion about how to query tables and the kinds of indexes we might want, the kinds of lookups we're going to do. This is, I think, well, let's start with that sort of transactional mindset where I'm doing a point lookup of a thing. Gee whiz, we know how to do that. We can have indexes of high cardinality fields that work extremely well, and you can have many of them if you need them. So that's a pretty well-known solution. The cost there is that I've got a little bit of extra infrastructure. Now I have a Kafka Connect cluster or some other kind of an integration technology that's going to go between my stream and my table. But it might be that I don't really feel that cost, because it might be that it's super cheap for me in terms of like cognitive load and operational load to spin up a Postgres instance, because maybe that's just a thing that you do. And it might be that I already have a Connect cluster because I need that for other reasons. So that could be super low friction and an easy and smart way to query a stream. And the latency isn't going to be super high. We're probably going to be able to make that point lookup happen fast. And the latency through Connect is not much. So that can be actually a very sensible way to do things. You wouldn't want to stand up all that infrastructure necessarily just for the purpose of doing that. But if it's there and it's easy and everything, well, okay, we've got a good solution. Also, I hinted at this, but if you need more than one index, this solution looks good, right? If I'm doing these point lookups, but not necessarily doing them by the same key, then a relational database is a great fit because I've got lots of flexibility there. If I want to do analytical queries on that data, where I'm scanning a large number of things and computing an aggregation, doing some filtering, again, completely possible. I mean, the modern history of analytics, I say modern, but I'm referring to 30, 40-year-old stuff, the data warehouse, that was all built on relational databases. So we used that storage engine and that query language and all that kind of stuff to do analytics queries. That's very much possible there. You're not going to see the capability of doing highly concurrent queries or very low latency analytics queries. They're not technologies optimized for that. So if you're doing more analytics stuff and latency matters and concurrency matters, then the relational database option is going to hurt a little bit. That's going to have trouble scaling. But point lookups of small things, small-ish things, that's a fine way to query a stream. Okay, so we got data lake, we got relational database, we have stream processor. Now, this is a big space. There's lots of different ways to do this. I'll just kind of zoom in on something I know fairly well and talk about it. This whole conversation, the original tweet by Robert, started with a discussion of Kafka streams and its so-called interactive query API. Now, that name, IQ, interactive query, I in naming things, as you know, is one of the two hard problems in computer science. It is a little bit misleading, I think, but the interactive query API is basically a way of querying a stream. So what I can do in Kafka streams is I can take these events. Remember, if we're thinking of the case where the events in a topic are not pure events, but they're updates on an entity, they're a thing I might want to ask about. There's an identity to a thing, and I want to see what's true about that thing. That's the transactional case, right? Of querying a stream. I can, in Kafka streams, turn that topic into a lookup table. It basically makes a hash table that's backed by RocksDB. So there's an in-memory component, and there's a persistent component, and there's a way that they scale out among instances in a consumer group, and a whole story there that we'll dig into in other episodes of the podcast. But I can turn a topic into a table, and then I can ask questions about that table. I can do a point lookup on a key in that table. So that's a pretty interesting way to query a table, especially in that transactional case. Kafka Streams gives me a decent way to do that. A lot of assumptions there, of course. I'm using Java. I want to write a Kafka Streams application. Other constraints of IQ and streams and everything all work out for me. But if you're a streams user, it is this way of querying a stream. I can also, that's the transactional kind of query. I can also do certain kinds of analytical queries with Kafka Streams. I could, for example, imagine I've got all my smart thermostats in the known universe reporting their temperature once a minute. I could group by postal code and compute average over the last 8 hours or something like that. That's a fairly straightforward topology to write in Kafka Streams. And now I've got this little group thing, and I can look up the zip codes or the postal codes in there and get those aggregates out. So I can do certain kinds of analytics and lookups. What's the constraint here, other than it being a particular product's API and all that stuff? And it's a Java API. So, set of opinions there that I need to make sure I can agree with. The other limitation here is goes to indexing. Okay, so underlying any one of these table structures in Kafka Streams, and the API object or interface is called K-table. Underlying a K-table fundamentally, and correct me if I am wrong in terms of any implementation here, but it's basically an abstraction on top of a Kafka topic. And a Kafka topic, structurally, the messages are key and value. And so I am able to do interesting lookups on that table based on the key, whatever the key is in that underlying topic. That's just how the topic to K-table mapping works. And whether that is a transactional lookup of thermostat by its ID, or a lookup of a zip code in my analytical query topology that I calculated, what I'm saying is I can have as many indexes as I want, as long as it's one. So I get that one index. So I can do these things, and it's a good and solid approach that fits in lots of applications, but I'm kind of limited in my indexing strategies and in number of indexes. I have to compute multiple of these topologies and potentially with different underlying storage backing topics and so forth in order to have multiple indexes, and that starts to feel like a lot of work. Which gets us to our fourth and final solution. And again, I'm putting it fourth in the list, and there seems to be a certain bias because this is the kind of technology that I work with and that the podcast is generally preoccupied with. I don't mean to say this is the final and best and complete thing that everybody needs to use all the time, but a real-time analytics database. So the relational database, our second way of querying a table, that is in fact a potential analytics solution. You've got SQL, you can do all those things, it works. You're just going to bump into some limitations, like I said, when it comes to the number of concurrent queries, the number of queries per second, query latency on analytics queries. If it's a lot of data, You might get a few queries per second executing. They might take a few seconds being pipelined in some way. And that's a long time. And if you're trying to, in this real-time stream processing application, say, present analytics data back to users at the level of a user interface, which is kind of the preoccupation of real-time analytics, right? Doing this in a user-facing way, the relational database isn't going to work out in the analytics case. It's probably going to work well in the transactional case, the point lookups, but not analytics. So if what I am doing is, I've got a stream, I want to ask questions about the stream. The questions, the two categories of questions are, what is this thing? That's one. The second category is, what has happened? That's the fundamental question of analytics. I want to get insights into what has happened. Ideally, if this doesn't sound too businessy for you, I would like them to be actionable insights into what has happened. That is kind of what we're doing with analytics. And if I'm ingesting streaming data, and there's any sense that I want to get these answers in real time to turn around answers to users in a user interface, that really is, that set of concerns is what has created this category of infrastructure. 5, 6, 7, 8 years ago, there weren't good standard solutions to this. You had to pre-compute aggregations and throw them in a key value store for low latency, high concurrency serving. And that is no way to live over the long term. So a real-time analytics database like Pinot is a place now where you can ingest that stream. And that's, Pinot acts as a, considering the Kafka case here, again, there's lots of ways to do this, but in the Kafka case, it's a native Kafka consumer. So you kind of just connect your Kafka topic to it. It ingests in real time, creates a table that looks like the structure of the messages. The fields in the message become columns in the table. And you get to define the indexes that you'd like to define. You get to build as many indexes on the table as you'd like. And you have kind of an interesting set of 10 or so sophisticated, in some cases, very sophisticated index types that allow you to do interesting queries on JSON data, on pre-aggregated multi-dimensional data. So I want to have average temperature by, I say I've got a dwelling type, single family home, apartment, condo, something else, and postal code and house size, some kind of buckets of square footage, those kind of dimensions. I could have an index type that in Pinot, it's called the StarTree index, no relation to StarTree, my employer, that pre-aggregates different combinations of those dimensions, and I get super fast lookups on that basis. There's timestamp lookups. There's an interesting set of indexes. I'm not limited to just the one. So when I need to get back to, database mode, the stream processor thing is perfect for these real-time computations, event at a time, extremely low latency, very, very flexible, and kind of streaming native, right? But I get out of database mode because I almost entirely lose the ability to index. When I want a table and SQL and indexes and to kind of feel like a normal person using a database again, the category of real-time analytics databases gets us back to that, where I can index the way I want. I can define a schema in a familiar way, the way I want, and I issue queries by describing them in SQL, and then they get executed. And this category of infrastructure, databases like Pinot, are engineered to be able to handle, in a meaningfully sized cluster, tens of thousands, hundreds, in some cases, hundreds of thousands of queries per second with low latency, low meaning, and obviously this is going to depend on the data and the query and all kinds of things, but there are real life latencies in the small numbers of tens of milliseconds, 15, 20, 25 millisecond P50 latencies on real data at scale with high concurrency. Can't do that in a relational database. Definitely can't do that in a data lake. Can sort of do it in a stream processor, but again, you're kind of hobbled in terms of indexes and there are other limitations to think about. So the idea, I think, here is that we are, in a real sense, en masse, making this transition to event-driven architecture from client server and its various children and cousins who have been knocking around for the last 40 years. And we're making this transition to event-driven services. And in that process, we've a little bit lost the knowledge of simply how to ask what is currently true and what has recently happened. We used to know how to do that because the world was centered around a relational database. But now in this new world, we really have to step back and think, well, okay, what does it mean to ask what has happened, to query a stream, and what are our options? So I think it's good to think through these ideas. Your choices here are always going to depend on existing infrastructure commitments, things the team is good at, what the actual business requirements are in terms of latency and concurrency, who's getting the data. Is it a dashboard for an executive or a business analyst? Is it a feature in the mobile app? And those are very, very different things. So you got to look at all that when you're deciding how to query a stream. So again, just some thoughts here, a little bit thinking out loud. I would always love to hear your thoughts on podcast episodes, but this one in particular. Be great if we could use this as a discussion starter. What do you think I've missed? What do you think I've gotten wrong? What would you add? I'd love to hear more. Thanks for listening.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.